Your PyTorch is running at 1 time speed. Your GPU can run the same math at 50 times speed. A single matrix multiply takes half a second on the CPU and 11 milliseconds on a graphics card. In this guide, we connect PyTorch to your NVIDIA GPU, step by step.
Check, install, verify, use. Every command is verified. Let's get started.
Here is the mental model you need. There are 4 layers. At the bottom, the GPU hardware, like a GeForce RTX 3080. On top of it, the NVIDIA driver, the only thing you install yourself. Above that, the CUDA runtime, NVIDIA's parallel computing libraries.
And the CUDA runtime is bundled inside the PyTorch wheel. So here is the myth. You do not need to install the CUDA Toolkit. It rides inside the wheel. And when nvidia-smi shows a CUDA version, that is the maximum your driver supports, not an installed toolkit.
Drivers are backward compatible. A new driver runs older CUDA wheels with no problem.
Step 1. Check your GPU. Open a command prompt and type nvidia-smi. You get a summary table. The top line shows the driver version and the CUDA version the driver supports.
The GPU row shows your card, like the NVIDIA GeForce RTX 3080, with 10 gigabytes of VRAM and current utilization. You can also check the Windows Task Manager on the Performance tab under GPU 0, and the Device Manager under Display Adapters.
If it says Microsoft Basic Display Adapter, your NVIDIA driver is missing, and that is the next step.
Step 2. Update the NVIDIA driver. Open the NVIDIA app. GeForce Experience has been retired, and the NVIDIA app is the new home. Go to the Drivers tab. Click Check for Updates. Then download, then install. Choose Express Installation, and restart your PC when prompted.
The driver renders your desktop right now, so Windows can't hot swap it. A quick rule of thumb. CUDA 12.4 wants driver 550 1.78. CUDA 12.8 wants 570.65. And CUDA 13 wants 580 or newer.
A recent driver covers almost everything.
Step 3. Get the install command from the official page. Open pytorch.org/getstarted/locally. 5 drop-downs. PyTorch build, stable 2.13. Your OS, Windows package, pip, language, Python, and compute platform CUDA 12.6. The page generates the command for you.
PyPep 3 install torch tortishoya with index URL. Download.pytorch.org/WHL/CU126. Note, latest stable PyTorch requires Python 3.10 or later. Copy that command and let's run it.
Step 4. Install the CUDA build. Paste the command into your terminal. Pip downloads the torch wheel, 2.59 gigabytes. That is the giveaway that this is the GPU build. The CPU-only wheel is just 122 megabytes. The CUDA runtime rides inside the big wheel.
The progress bar fills, and pip finishes with a success line. Torch 2.13 plus TU126 and Turgishno 0.28 plus TU126. That plus TU suffix is your proof of the GPU build.
Here is the #1 trap. On Windows, a plain pip-installed Torch installs the CPU-only build. PyPI only hosts GPU wheels for Linux. If you skip the index URL, you get the CPU build, and CUDA is silently unavailable. Detect it in 1 second. Print torch_version.
2.13 plus CPU, that is the CPU build. 2.13 plus CU126, that is the GPU build. The fix is simple. Uninstall Torch and Turgishno, then reinstall with the index URL from the official page. Always look for the plus CU suffix.
Step 5. Verify the GPU works. Open a Python prompt and import Torch. Then call torch.cuda. is available. True, with a green check. Get the device name. NVIDIA GeForce RTX 3080. Now move your first tensor to the GPU.
Create a 3x3 random tensor and call dot to CUDA. Print its device, CUDA:0. The matrix multiply runs on the GPU. Your PyTorch is now GPU accelerated.
In real training code, the pattern is always the same. First, pick the device. Torch.device, CUDA if available, else CPU. Then move the model with model.to-device. And move every batch, inputs, and labels with .to-device.
Forget the last part and you get the classic error. Expected all tensors to be on the same device, but found at least 2 devices, CUDA 0 and CPU. The fix is to move the model and every batch.
For faster data transfer, set pin memory to true in your data loader.
Now watch the speed. For a small CFAR 10 model, one epoch takes about 67 seconds on a CPU and about 12 seconds on a mid-range GPU. Roughly 5.5 times faster. Your numbers will differ by GPU and model.
While training, open a second terminal and run nvidia-smi-L1. It refreshes every second. Watch the GPU utilization jump from 0 to over 90% and the memory usage climb. Your Python process appears in the processes table. That is your training. Live on the GPU.
Let's fix the errors that hit everyone. First is available returns false. Check 3 things: the +Q suffix, the driver version, and the Python environment. Second, the RTX 50 series. Blackwell GPUs need PyTorch 2.7 or newer, built with CUDA 12.8.
Otherwise you get no kernel image available. Third, out of memory. Shrink the batch size and free cached memory. Fourth, on Windows, a DLL load error means the Visual C++ redistributable is missing. Fifth, nvidia-smi fails. Reinstall the driver and reboot.
Sixth, if you have an older GPU, stay on the CU126 build, because newer wheels drop support for old architectures. Every fix here is verified.
That is it. 5 steps. Check your GPU with nvidia-smi. Update the driver. Install Torch with the +Q suffix. Verify with is available. And use the .to-device pattern. Your GPU is live and PyTorch is running at full speed. No GPU? Google Colab gives you a free one with the same code. What is next? Vision transformers and model deployment. Like, subscribe, and comment. Happy building.